understand is Proactive Risk is a managed security services company. We do staff augmentations with people around the world and also deploy solutions for organizations. I am your moderator. I am also the founder of Proactive Risk and will help guide along the way with our presentation today. With that, I'd like to pass the ball to Steve and see if we can get this kicked off.
Thanks, Tom.
Hold on one second, Steve. And there you go. Sorry, I'm passing you the ball.
Appreciate it. Hi, everyone. Hope you're doing well. Thanks for joining. As Tom mentioned, my name's Steve Markey, and for the next couple of minutes, we'll talk about database cryptography. Now, I'll be frank. I know most of us like to multitask, and if I just drone on and go through PowerPoint slides here, you'll probably be bored to tears. So I get that. So I like to have interaction. So as I mumble on, if you have any questions, concerns, or if you want to add your 2 cents or more than 2 cents, please feel free. Fair enough? Tom, can you hear me? Am I coming through okay? All right, I'm going to take that as a yes. All right, so
yes, you're good. Go ahead.
When we're talking about database cryptography, we're talking about, in essence, 2 mechanisms. First and foremost, data at rest. Okay, that's the cryptography, encryption, hashing, obfuscation, masking, etc. We'll get into in detail. Then data in motion, which frankly is a little more subjective. It's the belts to the suspenders or vice versa. So with that said, let's get into the details, okay? I'm going to cover for DAR, I'll just say data at rest, DAR for data at rest, the protection levels, algorithm selection, performance considerations, and then relational versus non-relational, basically NoSQL databases. The next slide we'll talk about what is a database very quickly. And then last but not least, we'll talk about key management for DAR. Excuse me. And then in the context of data in motion, or DIM, as I'll call it, we'll talk about TLS SSL support. So moving on. All right, so these days, when we think about databases, I myself think mostly relational databases. The traditional Oracle, Microsoft SQL, MySQL, blah, 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 relational databases, but like life, it's a little more complicated than that. So I mentioned non-relational database management systems in the previous slide, NoSQL, right? We have relational, and this is a pretty busy slide here, but I think we'll all agree that in the context of enterprise application security, enterprise database security, the vast majority of what we're looking at are relational and/or now NoSQL as well. And NoSQL includes going clockwise from 1 o'clock graph, key value, big tables, and document, graph, document, key value, big tables, etc. And notice the as a service, right? So that's where we're talking a NoSQL database in Amazon or Google or a cloud provider's offering within their cloud stack, SaaS, PaaS, IaaS, SPI stack. All right, any questions so far? Okay, moving on. So one of the things I wanted to cover real quick beyond that we have different databases these days is that a lot of the database vendors are listening to their customers and responding. So there is a hierarchy in cryptography, and this is a slide regarding Microsoft SQL Server and the hierarchy of cryptography and key management and the different algorithms and protection mechanisms, okay? So keep that in mind. I have another slide where we'll talk about Oracle's wallet mechanism, which is analogous to this, but what I'm trying to articulate here is that this database cryptography is complicated and can be complicated or very complicated, predicated on your requirements and what you're looking to do. Speaking of which, talk about database cryptography, a lot of times we're talking about obviously encrypting or hashing, etc., data, but predicated on the requirements, what level are we going to? And so a lot of folks use file system cryptography. And when we say commercial or open source, TDE, transparent data encryption, that includes DMCrypt, right, for Linux systems, etc., or leveraging something from a vendor, a commercial solution. SafeNet, Vormetric, Voltage, etc. come to mind here. And basically, we are encrypting that mounted file system. Now, there's overhead, and we'll talk about that in a little more detail, but this is a safer method in the context of being concerned about backups and data loss protection, prevention, etc. You're encrypting the whole shebang, for lack of a better word, versus a specific database instance or a specific table or one-to-many columns, right? As we move further down towards the columns, what I'm trying to articulate here is you have more options in the context of, instead of encrypting everything and or relying upon an open source or commercial solution in an all-encompassing manner, we can leverage procedural solutions. And what I mean by that is an encryption user-defined function, UDF, right? Which you don't, in my opinion, you don't want to recreate the wheel and create your own function or method to leverage cryptography when you should use an API or a database vendor's method function already. But that could also be a procedure, store procedure, a trigger, a script, etc. But the whole point is that predicated on the requirements, and that includes PCI requirements, HIPAA requirements, statutory privacy requirements, FISMA requirements. There's a litany of different regulatory requirements out there that you may have to adhere to. And what we're trying to articulate here is there's pros and cons with all of them, right? As I mentioned, if you're trying to encrypt everything, there will be performance degradation. But if you're trying to encrypt one-to-many columns in the database because you're dealing with credit card data, etc., that can get complicated too. So it's not a silver bullet. I'm not going to sit here and say, well, this is what you should do in every case, because frankly, it's all about what system, what application, what requirements, what jurisdiction, what data. Okay, fair enough? Any questions so far?
No questions posted.
All right, moving on. So one of the things I want to try to articulate here as best I can is that when I hear cryptography, most of the time I think of hashing and or encryption, right? But nowadays you also have tokenization, stateless and stateful tokenization. You also have obfuscation or pseudonymization. We'll talk about some of that stuff in the next slide as well. But when we're talking cryptography, a lot of times it's encryption or hashing, but we also have hashing, masking, tokenization as well. And in the context of what your requirements are, sometimes you need to do masking as well as encryption. And that's belt and suspenders, but hey, if you have to deal with the PCI DSS or some of the HIPAA requirements or statutory privacy requirements, they have some specific guidance on what data needs to be masked, and then you may want to encrypt that data as well. So it's all about the requirements and everything, but there are plenty of options out there. Furthermore, I wanted to say that tokenization is, in my opinion, a subjective term, but you can leverage a UDF, user-defined function, or a custom algorithm API for your own tokenization, but there are commercial solutions out there too. Voltage comes to mind. And again, that can help you in the context of being able to consolidate, aggregate, and have a common data dictionary downstream when you're dealing with one-to-many data providers. And what I mean by that is, let's say you're an analytics firm or you're a social media company, etc., and you're gathering data from multiple sources. that tokenization API can satisfy your protection as well as your ability to leverage said API for making sure that J. Smith and John Smith are associated in a similar manner, okay? With that said, any questions so far? All right. So when we're thinking of cryptography, again, I think encryption a lot. And as most of us may know, you have symmetric versus asymmetric algorithms, etc. Now, in the context of data at rest, DAR, most of the time we're looking at symmetric algorithms. And as you look here, hopefully everyone can see that small verbiage. For Microsoft SQL 2014, you have a plethora of symmetric encryption algorithm options. And this goes back to your options, right? I prefer AES 256 or stronger. I just feel it works, and the applications I've written, applications I've audited or assessed in the context of pen testing, blah, 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 I just find that for me, it's the go-to, but that doesn't work for everyone, right? Asymmetric in the context of most deployments we know are usually PKI, public key infrastructure. Asymmetric deals with two keys, right? So I haven't really seen that used in the context of cryptography for databases, but that doesn't mean that there's no use cases there. Some of us may know where we have analysts and or data processors that are using Excel and or some type of OLAP engine, etc., and through ODBC, JDBC connections, they're doing that connection or coupling, for lack of a better word. Anyhow, moving on. So in the context of cryptography, I want to ask a rhetorical question here, and subjective one. Does the key length or cipher strength, does it mean that it's stronger or the security is better? And that's predicated on your requirements. Again, if you're concerned about performance, you may want to go with a slightly less secure or strong algorithm with a key length, shorter key length, but you may need to implement compensating controls, right? So that's where you may want to look at when we're talking about data in motion, DIM, leveraging SSL TLS for that JDBC, OCI, or whatever connection, right? Predicated on the fact that you're leveraging a three-tier architecture with separate VLANs for the different tiers, right? Any questions so far? Comments?
Steve, there is one question. Right. Steve, there is one question that came in. The question is, can you describe tokenization?
Okay.
Could you describe tokenization?
Sure.
Thank you.
All right. My description of tokenization is where, in essence, it's a custom hashing algorithm almost. That's what I think of tokenization. That may or may not include masking. And so let's say you deal with a system that uses social security numbers, tax IDs in a manner for primary keys or not, some type of identification scheme. So if I was to leverage my own tokenization algorithm, I would mask 1 to, let's say, 4 or 5 characters of that social, and I would, in essence, do a bit flip or some type of shell game, if you will, to rearrange it, but rearrange it in a manner where, again, John Smith from data provider A and J. Smith from data provider B, and that's our record, right? John Smith, J. Smith is, let's say, a patient in an electronic health record system or something like that. Through tokenization, again, some masking, some flipping, we still have our identifier that is meaningless without the API or algorithm to an outside party, yet means something to us. And that's why we also see tokenization leveraged fairly highly within PCI DSS cardholder data deployments, right? Where PCI says you can't store the PAN you have to mask it in some way, shape, or form, and you need to provide additional security on that. You have some security providers like Voltage, and FYI, I'm trying to stay vendor neutral agnostic, just Voltage comes to mind, and they have a commercial tokenization, but I also just alluded to a custom tokenization algorithm API that can be leveraged, again, to perform a custom hash in essence. So this is where you feel SHA or MD5 or whatever is either not strong enough or is not providing the flexibility and the autonomy you need to be able to downstream leverage that token for identification purposes. So that's my extremely long-winded definition. All right, so moving on. I wanted to leverage this little screenshot here because when I think of cryptography, etc., first off, I think of leveraging encryption, hashing, etc., at the application level, right? Though you can leverage the commercial database or open source databases, algorithms, UDFs as well, right? Or, excuse me, functions, not UDFs. But notice here in MySQL, and we're at the command line up above, right? Linux box, whatever. And here we're setting up the block encryption mode and, in essence, settings and configurations. Speaking for myself, I don't do this that much, right? When I'm looking at using cryptography of data, etc., I'm looking more on the application level and or leveraging what's out of the box per se in the context of MySQL, Oracle, blah, blah, blah. But there are plenty of options out there to include the actual block to use, right? ECB seems to be one of the better choices here, but there are configurations that a DBA, a developer, and or a security architect or enterprise architect can make to help configure the box correctly. Any questions?
There are no
All right, moving on. So performance considerations with DAR. This is a balancing act. The stronger the crypto, the more the performance hit. And as most of us, I assume, are developers and or technology folks leaning towards security on this call today or webinar today, I think most of us like the belt and suspenders or compensating controls, right? Think of the analogy metaphor of a castle with physical protection mechanisms, etc. So this is a balancing act, as I just said, and it's all about what is the main business requirement, functional, non-functional, and how do we work with that and secure the data as much as we can, right? If we're talking an integrated voice response unit, in essence, when we call a toll-free number for our bank or financial institution or a healthcare provider, et cetera, and we get that automated phone system, that's IVR, BRU. So let's say that's incorporating some sensitive data we need to protect, right? That's where, in essence, hopefully the business analyst, the project manager, the business owners, et cetera, can identify, excuse me, their performance requirements in a specific objective way, right? And then we have to leverage the requisite protection mechanisms to fit those requirements. So going back, the protection level, the algorithm, are huge determinations to affect our performance. But I also want to talk upon or discuss the decryption alternatives. As Tom and crew with OWASP have advocated over and over again, you should do a one-way hash or encrypt without decrypting data. And I'm just going to jump ahead a second here. And here I have some code snippet, Java, doing prepared statements, everything else. And what I'm doing is I'm running a query, and I am comparing user provided password to a password stored, encrypted in a database here. So what I'm trying to say is, for performance considerations, for security considerations, there's really no need to decrypt that password in the database. What you do is you do your client-side validation, you encrypt the given information, here it's a password, and then you compare the two, right? So look at the while statement, the loop below. If we have a match, we'll have a result set, right? It's going to, if that password that we just encrypted that came from a HTML5 form, whatever, matches our password in the database, then we'll get, hopefully, one result set. And I'm just saying, hopefully, that it's not more than one, but you get the point in the context of we'll have a hit in the query, right? It will provide data. So that's where we're comparing ciphertext, okay? I also want to mention homomorphic encryption, or HE as I call it. And that's not high explosive for the Marines on the call, Tom, right? So here, homomorphic encryption, HE, can do computations on ciphertext. So it doesn't need to decrypt that data to plain text. And here I have some more Java code snippets where, in essence, if you look at the output down below, okay, I have 112 and change on the second paragraph, for lack of a better word. And then I also have 103,454, and I can easily do that computation, that addition, without having to decrypt the ciphertext or change it to plain text. So HE provides some, although it's not mature, it provides some hope for us where we can have proper cryptography without performance degradation. Or I should say significant performance degradation. And then, last but not least, when we're talking DIM, right, TLS, SSL, that can affect performance as well. So that needs to be taken into account. All right, so with that said, I pulled a couple of these bullet points off of Microsoft's website. And I think a lot of these are common sense thought points, but hey, it always helps for reinforcement. So as I toggle along here, any questions?
Yeah, Steve, we have a question that came in. Question came in is, why are you encrypting the password and not hashing it?
Why am I encrypting the password? Right. Well, I don't want to have plain text passwords in a database. Matter of fact, in a optimal world, we won't be using the database per se to store passwords. We'd be using LDAP or some type of single sign-on solution. So in this case, what I have is I have a simple Tomcat 7, HTML5, JSP, front end, and MySQL for one of my products in UAT. And just because I don't want passwords stored in plain text on my database, because I made a choice not to do table and or database instance cryptography. I am using TDE for the file system, but I just didn't feel comfortable with storing passwords, even though it's a UAT environment, in plain text.
Great, thank you.
All right, so I don't know the maturity or our familiarization with NoSQL, but I'm going to cover that as well. And when we're talking about NoSQL databases, etc., I'm thinking most of the time more of a Web 2.0 or social media use case. While the industry is moving forward with leveraging NoSQL, et cetera, for enterprise data. In my opinion, it's going to be a while before relational databases are gone. So anyhow, as we look at some of the more prevalent NoSQL commercial deployments, Couchbase, Mongo, Cassandra, et cetera, they do have cryptography options, either built in or via APIs. With that said, and I think it's just due to they're relatively new on the scene here, the cryptography is not as mature as we've seen with Oracle, Microsoft, etc. So here we have an example of Amazon Dynamo, some data, log data for SIM consumption I created. And NoSQL is meant to be very open and not to be as rigid or as a relational database. So if you think about that, that can, we're in essence thinking a lack of access controls most of the time. And obviously, for the security folks on this webinar, that can be a concern. So anyhow, we need to have compensating controls. And most of the time, I advocate on the web or application tiers, that's where we need to have the compensating controls. With that said, as I mentioned, we can have file level or database instance in cryptography deployed. But anyhow, as I have some examples here, through the NoSQL, the more prevalent NoSQL deployments, okay? And again, I'm trying to stay Switzerland here, neutral agnostic in the context of vendor commercial options, but these are more of some of the more prevalent NoSQL solutions out there, and they do have either procedural or commercial options for doing column-based or even database instance cryptography. Any questions so far?
One more question, Steve, that came in is, where do you recommend storing the salt? I commonly see them stored in the same table with encrypted values, which doesn't make much sense to me. What's your opinion?
Well, it's fine that just came up as I'm at the key management slide. In the real world, meaning production, I want the salt or the keys stored as far away from the database as possible. Now, I'm advocating that we do crypto at the app level, not the database level. And I'm advocating against what we see with this slide with Oracle, with the Oracle wallet. Now notice that's a file, so that is, in my opinion, a metaphor for the key, the master key being outside the database. But notice how we're talking table column encryption keys within the database. Again, I'm not a fan of this, and let me toggle through as well. This is Microsoft's version, very analogous, in my opinion, to what we just saw with Oracle. So, again, key salts away from the database. Frankly, they should be away from the app server. It should be away from the web box or proxy. It's not always feasible, but you should have a key management server, one to many. And what I'm thinking of here, this is a DBA, a database administrator's world that we're kind of looking at here. Now, if you have the requisite pool, cloud, and time and resources, I know that's a lot of ifs, as an enterprise security architect, CISO, director, VP, AVP of AppSec, whatever your title, whatever your responsibility, if you can get with the requisite people before this is already built, I want the keys, the salts, all that away, again, from the database, the app server, the web server proxy. But that's not always feasible. That's not the real world. And that's just best practice. Fair enough? All right. So I know I'm jumping around. I apologize for that, folks. So again, handle at application level, dedicated key management server. That's not always practical, right? And as we'll talk about TLS, SSL, I'll talk about Java Key Store with internal or CA-based PKI, etc. I also want to touch upon crypto shredding. One of the data retention or disposition processes I see becoming more commonplace or advocating via the Gartners of the world, etc., is crypto shredding. Now, whether it's OWASP or ISC Squared or some of these other organizations, CSA, Cloud Security Alliance, etc., I've sat on working groups with people, extremely bright people who are juiced in as well to the industry, and they have looked me in the eye and said, I have spoken to judges, and those judges are technically savvy enough to understand what crypto shredding is, and it's a viable option. I've heard it. I haven't seen it explicitly, but it is out there. But if you're doing crypto shredding, and let me explain crypto shredding. I apologize for putting the cart before the horse here. Crypto shredding is where instead of deleting or disposing of data, electronic data, you get rid of the keys. Now, one of the things I also forgot to mention here, the salts, the keys, all that, move it off to a dedicated key management server. But rhetorically, what do you need to do then? Well, you need to back up that key management server, right? And if we're doing crypto shredding, and maybe your organization does it or not, I'll be frank, I'm very concerned, I'm very scared about the backups. And where are they? Are you using a vendor like Iron Mountain or someone else, and those backup tapes are off-site? Could you have a tape lost in the shuffle on-site or with Iron Mountain or whoever, and all of a sudden, litigation comes up. And the other party finds this backup with your keys. Now, all of a sudden, you thought you had information that's been disposed of, and it's not. Food for thought. All right, moving on. Any questions with that?
Sorry, Steve. There is one more question
Okay.
that came in.
I'm not going to walk through all this.
Sorry, Steve. There is one question that popped up. The question is, what is the length you recommend for a salt? Do you recommend the salt being added before or after the string?
I think it should be added before, and recommend strength. The stronger the better. I know that's very subjective and nebulous, but it's all about what your requirements are. I can't give you an answer for that or a silver bullet. Let me say this, okay? I was working with a client, a SMB, that had that was audited, SOC 2-like audit from a healthcare provider. And the healthcare provider advocated AES 512. And I know that's not the salt length, strength, etc., but my point is that this was a growing company with maybe 25 full-time people. And this was the entity mandating this was a large healthcare system. And the reality is this small business wanted to have this large healthcare entity as a client. And believe it or not, we found middle ground, all right, AES 256, from the fact that they did not even have a full-time security person, right? They didn't have a very big, large technical team. So predicated on what type of data we're dealing with, that's all the length can change. But I advocate that predicated on a fixed salt length that you put beforehand. Have it be a prefix, because it's much easier, in my opinion, for the developer to be able to do a substring-like operation when the salt's a prefix versus a suffix. Fair enough? All right, moving on. OWASP has some key guidance here. Again, I think a lot of this is common sense, but it always helps for it to be reiterated. All right? So I'm going to move along here. I'm sure you're pretty tired of hearing me talk. I'm almost tired of hearing me talk. So when we're talking DIM, right, to complement DAR, again, this is the belt and suspenders action. And I enumerate a lot of the ways to access different databases and predicated on who's doing what, who's connecting, are you incorporating AD or whatever NOS for auth that or some type of SSO, predicated on your access controls, predicated on who's connecting, predicated on what they're accessing, predicated on whether you've separated your data tier to your app tier. All these variables will invariably change what you use to connect with, and frankly, how strong, if any DIM security should be used at all. And this is all about the balancing act. I have not used many more, a vast majority of my experience is ODBC, JDBC, right? College, etc., OCI, SQLNet. I've done some link with .NET, EJB stuff, yeah, JPA, blah, blah, blah. But this is this is quite the enumerated menu selection of ways in which we can connect to a database these days. And again, a lot of these do support TOS SSL connections. But this goes back to performance, and this also talks or goes back to asymmetric. We're talking PKI here. So we have a lot of options and a lot of thought points. Are we doing Java key store or something analogous for internal? Are we using external, Komodo for CA, whatever? A lot of this comes into play. Furthermore, I've seen organizations where they have an outside party doing the DBA work. They have an outside party doing the network administration, this, that, and the other. That can make this a logistical nightmare. So just be careful, right? Sorry, that moved there. Anyhow, predicated on what your requirements are, you may want to use TOS SSL explicitly and solely for your connections. And NoSQL does provide TOS SSL for DIM as well. All right, so, excuse me. I wanted to quickly touch upon this. Notice how we have in the middle here of this visual the web tier talking directly to the database tier. This is a use case, in my opinion, where we'd really want to use SSL TOS. Why? Because, in essence, you have to punch a hole through a firewall gateway to, in essence, I hope this is your DMZ on the web layer, to your data tier. And that's where, in my opinion, this is a huge use case for TOS SSL. If you're going through the app server or the app tier, and the app tier is a traditional standard 3-tier architecture, well, access controls and compensating controls may mean that you don't necessarily have to explicitly use TOS SSL for 3306 or whatever port, etc., for data transfer between the app and data tiers. Any questions so far?
No new questions. Go ahead.
All right, moving on. So where do we go from here? I know most of us have heard of BYOD, the prevalence of cell phones, mobile, blah, blah, blah. We now have SQLite or analogous technologies that are doing data storage on devices. And frankly, I've not seen that much in the context of database cryptography on the device itself. Now, I know a lot of you are thinking, well, Steve, Apple, iOS, etc., they have the requisite crypto on the device itself, in essence, TDE. And you're right, but those things can be jailbroken. What about droid support, blah, blah, blah. So it makes sense to just mention this and say that if you're going to go to the level that Oracle or Microsoft are advocating for your data tier, it warrants that protection on that mobile device. And let's be frank, if you have an IT auditor worth their salt, and they're looking at explicitly a mobile deployment, they should be able to pick up on this and ask about it, all right? Also, I wanted to mention this as well, that there are desktop database deployments where, in essence, a vendor will leverage Access or Open Database or whatever in a flat file-like way for that thick client or mobile device or whatever install. Acunetics and some others will actually have Microsoft Access as the back end. And so that's where it makes sense. If you're doing something modified, whatever, you may want to ask the vendor, are you explicitly doing crypto on that database? So that's it, folks. Don't want to be too long-winded here. Any questions?
No questions submitted, Steve.
All right. Well, thank you. I appreciate your time.
All right. Well, with that, there will be some additional Proactive Series webinars coming up. Please stay tuned for them. You will get an email with a recorded link to this presentation if you wish to share it with anyone else. And with that, we'd like to thank everyone for their time and give you back 15 minutes of your day. Thank you.
Thanks, everyone. Take care.